Multiple choice questions. Amount of substance: 30 centimeters cubed of xenon mixed with 20 centimeters cubed of fluorine. It's a 1-to-1 molar ratio, so therefore we've got 10 centimeters cubed of xenon in excess, right? That's 10 left. And because of 1-to-1 molar ratio, I've also got this 20. Therefore 20 plus 10 is 30. Question 10. What's volume occupied by this, this and this? PV equals nRT. Volume equals number of moles, 10.8 divided by the MR of freon. I'll just Google it. MR of freon. 137.4 times by 8.31. I've got a meters cubed and I want it in either dm cubed or centimeters cubed to convert to dm cubed times by 1000. So just get rid of that. So it's 2.02 dm cubed. It would be times by 1000 centimeters cubed. CO2 MR. So in this case it would just be 2.65 divided by 12 plus 16 plus 16. 0.0602 moles. In this case, well, PV equals nRT, N equals PV divided by RT is going to be pressure in pascals times by volume 0.0150 meters cubed, volume measured in meters cubed in ideal gas equation, divided by 8.31 times by 1000. 0.0595 moles. In 3 and 4, well, I've got it in dm cubed and I've got it in centimeters cubed. Meters cubed, dm cubed, centimeters cubed. That's how I would memorize it. Just go like that and remember to go from one to another times by 1000 from opposite ways, just divide by 1000. So I need dm cubed in meters cubed, so it's going to be 1.50 times by 10 to the power minus 3 times by 200,000 divided by 8.31 times by 327 plus 273, because we want in Kelvin. We get 0.0601 moles. And in this case, it's going to be 1500 times by 10 to the power minus 6. The answer is A. nRT find out the volume. Volume of oxygen. So I can find out the volume of butane and then just times by 4.5, 0.1 times by 8.31 times by 295 divided by 100,000. But while volume is measured in meters cubed, I want it dm cubed, so I need to times by 1,000. 2.45, but then I need to times by 4.5 because I want the volume of oxygen. And therefore I get 11. Question 11. Which one of the following examples of gas when sealed in the volume of that is the highest pressure? PV equals nRT. Pressure equals nRT divided by volume. So it's going to be the number of moles of helium. 1.6 divided by helium. I think it's 2 or 4. Yeah, 4. Times by R 8.31 times by 100 temperature divided by the volume. It's in meters cubed, you don't need to convert it. For methane, 1.6 divided by 12 plus 4 times by 8.31 times by at 100 Kelvin divided by 0.10, 831. Oxygen, 1.6 divided by 32 times by 8.31 times by temperature, 600 divided by the volume. It's already in meters cubed, 2493. And sulfur dioxide, 1.6 divided by sulfur, 32.1 plus 16 plus 16 times by 8.31 times by temperature, 1200 divided by the volume, 0.10. 2489. The answer is A, highest pressure. And then question 3. Two sealed flasks of the same volume are left side by side. Both gases at the same temperature and pressure. Which gas could be in flask B? I've got the moles, I've got the mass of different gas. Let's convert this mass into grams and divide by 1,000. So it's 0.30 grams. Now I can find out the MR, moles equals mass, for the MR equals mass divided by moles, which in this case is just going to be 0.340 in grams divided by 4.0 times by 10 to the power minus 3. 0.340 divided by 4.0 times by 10 to the power minus 3. MR equals 85. And therefore all I have to do now is find out the one which has an M of 85. In part A it's 12 plus 2 plus 35.5 plus 35.5. That is 85. Therefore the gas could be flask B is that. And let's check the others. Obviously I already know part A is correct, but let's just check it. 1 plus BR, which is 79.9, 80.9. That can't be right. KR 83.8. That can't be right. PF3 31.0 plus F3 19 plus 19 plus 19 88. That's not the correct MR. Therefore the answer is A. And that's the end of the multiple choice questions.